Assalamu alaikum. Uh, my name is Jahidul Islam. My ID is 22408026. Uh, um, Today my topic is software architectures in embedded system. My today's topics are round robin scheduling, function queues, RTOS integration, and embedded modeling. Let's dive into that. Uh, So, uh, the fundamental concept for building robust system, we need mainly a system structure, component interaction, then quality attributes, real-time applications, etc. Now, let's talk about round-robin architecture. Mm, it's a foundational approach process scheduling. It's a simple scheduling technique, fair CPU distribution, circular execution order. Uh, the this operational workflow of round robin is first of all there are task queue, time slice execution, requeue, complete that. It's a work like FIFO, first in first out, basis for initial entry. It ensures no signal task monopolizes the processor. Cycle repeats until execution is complete. The advantage of round robin is the simple to implement fair distribution, but there are some disadvantages where priority is so high, it's not suitable for that, and it could be real-time inefficiency. Uh, Now, function queue scheduling is a modular approach to task management in embedded system. Uh, function this feature is function based storage, execution logic, etc., etc. um, Key features is event driven execution, dynamic function management, embedded system efficiency, highly optimized for embedded environments where resources are constrained and performance is critical. The advantages of function queue scheduling is flexible and modular, then efficient task handling. Disadvantages is queue overflow risk. Without proper limits, the function queue can grow uncontrollably during high load, leading to system crashes. The authority should be careful when they managing the something in function queue scheduling. Uh, Now let's talk about what is RTOS. It is the backbone of time critical embedded application, specialized for real time deterministic execution, guarantees that critical tasks are executed within defined deadlines, offering predictable responses to external events. Uh, RTOS types based on time constraints, hard real time. There are the in that slide you can see the different types of RTOS. Uh, Soft real time, this is flexible and based effort. With hard real time, it is deterministic and critical. Uh, then the architecture of RTOS key features core mechanism ensuring deterministic behavior. There are priority based scheduling, interrupt handling, multitasking. Benefits of RTOS is like highly reliability, predictable performance, critical system uses. If I say about critical system uses, the industry standard for safety critical applications like medical devices, automotive automotive control units, and avionics. Uh, Embedded program modeling in single processor system is a fundamental architecture for sequential task execution. Centralized processing, a single CPU is responsible for handling all computational tasks within the system, managing resources and control flow from a unified point. Execution model is tasks are executed either sequentially in a simple loop or via pseudo parallelism using time slicing where the CPU rapidly switches between active tasks. Uh, then program modeling. We previously we talked about the single processor system. Now we will talk about multiprocessor system. Here multiple CPUs and cores system architecture that utilizes more than one central processing unit or core to distribute workload, enables simulations execution of multiple processor of threads, significantly increasing system throughput, delivers superior computational power and responsiveness compared to single processor architectures. The key modeling concept, this is the essential principles for designing a robust embedded system. Uh, Time synchronization, processor communication, load balancing, uh, etc. Development process, embedded software lifecycle phases is like first of all requirement analysis, then system we need to design the system, then we need to implement writing code, driver development, initial integration, then we need to test our system, and then we can deployment. We can go our deployment phase. This is the life cycle of embedded software embedded system. Best practices is like hardware software integration, debugging and testing, performance optimization. We should be careful about that. Then tools and technologies, essential instruments for building robust embedded system. We need cross compilers, debuggers, hardware probes, um, and then simulation and emulation tools. What we need for the system for optimizing the system. Lastly, we can say the trailer architecture. Different architectures suit different needs. There is no one size fits all solution. Selection depends on system constraints. RTOS is best for real-time system where meeting strict timing deadlines and deterministic behavior is critical. Proper architectural choices directly improve systems efficiency, scalability, and long-term reliability. And that's all about the software architecture in embedded system. Thank you.